Hi everyone. So yesterday we had built the procedural fences. So we had solved a lot of issues where the fences were not quite aligned with the spline. So please check that out yesterday's live stream as well. I will add the link in the description. So today we are going to add some additional features on top of the existing functionalities. For example, we are going to test the horizontal alignment as well. So far it's vertically aligned. So there are also fences that have this horizontal alignment. So we are going to test that. And if time permits, we also will implement the gate. I mean, a fence can have one or more than one gates at any point of time. And also we will see how to incorporate different type of fencing within the same code base. All right. So let's just start. So let's see if the horizontal alignment works because we have secondary meshes and then we have the main column. So for the main column, if we do it like in the horizontal alignment, so nothing happens because the horizontal code alignment code is not yet written over here. So yeah, so the only thing we are doing over here is the dimension. So we will just work on this currently. So for the main column, we are having, yeah. So when fence is being generated, this is the code for the main column. The location, it is the distance is being computed in this while loop iteration, and if as long as the distance is less than total length, a new fence is being generated. A new, I mean, vertical beam is being generated. All right. So the idea is if it is horizontal, then it should be the length, the dimension along the x is going to be defined by the distance itself, and the dimension along the y and z will be fixed. I mean, will be user defined, but the x is going to be defined by the length. And for the vertical, the dimension is actually over here. If you can see, it is the entire all. I mean, all the three axes of the dimensions are basically user defined. All right, so let's uh let's now understand how to do that. So when the alignment is horizontal and desired dimension, let's check this out. So this is going to be for the main mesh. So if I am setting this to horizontal, the code is being working over here. Yeah, the desired dimension of x equal to mesh input and dimension of x. So this is not correct. So we need to consider the distance. So for the mesh info, we have the distance. Just 1 second. Let me just, yeah. We have the distance of like 250. So that's going to be the dimension. Let's see if this works. Sorry, distance. We'll compile. Now, right, vertical is fine, and then if horizontal, yes. So now it is occupying the entire length, but yeah, there are additional things that we need to set. So, but just check this out, how this works. So yeah, this is working fine, but what we wanted was a series of horizontal beams laid up. And this is also an use case where we want some of the fences have the entire wall throughout the distance. So we call that as, yeah, the I mean, fence wall. So if we are when we are building fence wall, we will have the dimension along x and along y and z also like this, but for this we need a smaller dimension along the z, so we will set the z to 25. Even smaller is going to be fine, like y and z can be like 15 by 15. This is going to be fine. And second thing we want is we may want more than one horizontal beams, and we may want to add them over here. And then finally we have to fix this gap. So this gap may or may not be there based on the user definition, but currently this gap is coming by default, so we will just see why this gap is coming right now. Right. So location equal to fence component. The location is being added from here itself, so let's check this out. Location current distance equal to 0. Yeah, so we have to set the current uh over here. Yeah, we need to check this out, get relative location. So first it is okay, let's just add a parameter that is going to specify how many fences are going to be added in a horizontal alignment. All right, so let's do something else also. Let's check this out. We keep this vertical, distance is 0, so and the dimension along x is, let's go 250. So that's also, yeah, the secondary column is gone, but we will all fix that. So that also means that this is entirely a set of horizontal lines, right? And we can do something like, if the orientation is horizontal, then we can use this calculation. Just hold on. Yeah, that is why the gap was coming, because for the horizontal alignment, I mean this gap, I mean this was set up for the vertical, where this dimension is also being computed for calculating the distance, but when it comes to horizontal, things will be a little different. So if the distance is reducing, so this is actually going to 0, so we have to make a lot of modifications when it comes to horizontal. Okay, so first thing we are going to do is, like, instead of having it based on distance, okay, this is also making it come. Yeah, so if the x dimension is 0, when it's horizontal, we can set it something like that, like dimension is set to 0, because this x dimension is automatically computed by the distance. Right, so we have a lot of settings to do over here. First thing we are going to do is, Let's forget the secondary columns for once, and let's focus only on the main columns. If this is 0, then it's 0, it's fine. Here, so the location is being calculated by the current distance equal to 0, then it is the location, or it's being calculated as a previous location for the next one. And here the previous location is, yeah, here you can see direction into the main column distance, and the main column distance is being calculated. Yes, here you can see it is being the dimension and the distance both are being added over here. So if the dimension is 0, then only the main column distance is going to be the exact match of the, but if the dimension is 25, then you will obviously see the gap, because the dimension for the x axis dimension for the horizontal is being still calculated just by the by this distance. So we can do something like, when it is horizontal, okay, let's keep this vertical for now, and we set the distance to 0 and dimension to, let's say, 250, and a small distance of, let's say, 5. Yes, now we see a little bit of gap in between. So even with vertical, if you set it like this, it's going to still be a horizontal, because now it is taking the dimension along the x-axis. So we can use this to our advantage. So now we can set up a parameter that is going to define two things. One, how much it is above the ground, because it is currently at the laid at the ground, and we may want fencing that is above the ground, that starts from above the ground, the horizontal beams at least. So how much it is above the ground, and secondly, how the defining the number of fences that is going to appear. All right. So when the orientation is horizontal, then two additional parameters are coming into place: the minimum distance from the ground, and this, and distance between the vertical distance between each of the fence, if there are more than one fences, and how many fences to be generated. Okay, so let's add a property over here for our mesh info. We want a few property, like, let's categorize. Although I don't think the category work inside the structure, the category don't work, but still, just in case. Uh, so this will be, first it will be float mean distance from ground, then it is going to be distance between row, distance between fences, distance between beams. Let's say this is something like 20, and this is something like 50. Then we have number of beams, 32 number of beams. So we have three parameters. Okay, now what we're going to do, we're going to check for the orientation. If this is vertical over here, if the orientation is horizontal, then we can do something. We already have the distance parameter, so we are going to not add another distance over here. We will use this one only. Okay, so here, if the number of beams, if it is horizontal, then for creating the fence column at the given location, it's going to stack up based on the number of beams over here. So here here we can just add a maybe for loop, then main column dot number of beams. So if main column, sorry, main column dot orientation equal to e mesh orientation horizontal, then this is going to work like this. Okay, main column dot number of beams, and when it's vertical, then we'll just do this. But when it's horizontal, then we have to create more than one fence at the same location. And I will add few additional parameters over here. Float distance from ground. Okay, I will get it from here itself, from the mesh info itself. So I don't need to add an additional parameter. If it is horizontal, then let's check the desired location. Yes, I will just add a distance from ground. By default, it is going to be 0. But if it is horizontal, then this is going to be mesh info dot distance. I will comment out this for now because I can also set the dimension as we have seen from here. So here desired location dot date, this will be plus, so this will rise up a bit. Okay, and another thing that I'm going to do is number of beams. So I have to, over here I'm getting the number of beams and I'm generating the column, but I have to add the uh, z offset as well. So I will just add a z offset additional parameter over here. So by default it's going to be 0. If even it's vertical, it's going to be 0. But if it's horizontal over here, then this is going to be calculated based on I index into main column dot uh, main column dot distance. This can be the z offset, right? Initially it's going to be 0, but then it is going to be 0 into something, and entire thing is going to be added with the mean distance from ground. Distance from ground equal to is going to be mean measured product distance plus z offset. Okay, or I can just also add it over here. Let's see if this works now. So for horizontal, number of beams can be set to. Okay, let's see. First, let's see what's the issue with the vertical. Oh, this mesh has gone. I mean, whenever you add some additional parameter, the settings get reset. That's something which is kind of like a bug of Unreal. We have to. I think we had cube, right? The cube. Also for here, cylinder we had maybe. This cylinder we have, right? And distance and height, and for this dimension is going to be, 200 and maybe 150. Okay, now let's check for the horizontal. Oh, yeah. First thing, the we have to fix this. Mean distance from ground can be. Oh, here for the horizontal, we have to first set the dimension along the x, and don't worry about the vertical. We are don't worry about the secondary means. We are going to fix that, and also distance is going to be something like 5. And this is something 15. 15, and then we have number of mean distance from ground is going to be, this distance is going to be like 5. Oh, now it's working perfectly. If I add mean distance from ground, why this is not working? We will fix. We will see why this is not working. Oh, I no. It has to be mean distance from ground. Distance from ground plus yes. Okay, we were not using that at all, right? We are using distance itself for this. So I will delete that. Yeah, we are going to use the distance because for horizontal distance variable has no other purpose, so that is where we are going to use it. So let's compile it again. I think again this is going to get reset. Yeah, again everything got reset. So now I will set the number of beams, let's say 2 by default. Let's set a default value for this. Is horizontal. Then distance is going to be, let's say, 5. This is going to be 15, and this is going to be 250. If I increase the distance, number of beams can be like 3. Yes, something like that. The distance is even more. Yeah, it is working perfectly. Now let's say the number of beams is 2. Okay, we can do something like this, right? We got a horizontal fence, but now we are going to figure out the gap that we are getting between the fences. When it is vertical, you think it's 150. You know what? It's a bit inconvenient to every time I change from vertical to horizontal. I again have to reset the dimensions and all. So let's do one thing. For the horizontal, we will take the z value as the x value itself. For example, if I switch this 160, 15, 16, it's the same thing, right? So why not do that? Let's do that. Because when it is horizontal, here I am setting the desired dimension, setting the desired dimension, so I can just desired dimension dot. Is there anything of swiping? How do I swap? Swap. There is nothing of swiping. Anyway, so I will do desired dimension dot x equal to float z dimension equal to z float x dimension equal to desired dimension of x equal to z dimension. I'm just interchanging the dimension. We don't need this at all. We can simply do it like yes. Okay. Now let's check. If I set this to horizontal, then yes, this is perfect. This is what I was looking for. Although, yeah, these we have these issues, but yeah, we are going to figure this out. But exactly what we wanted, and reduce the width far further. And this distance, if I increase the distance, we need to figure that out because this is going to be the horizontal distance, and the vertical secondary meshes should not be affected by that. So we have to also implement that. So what's the first issue that we're going to solve? Let's check this out. Yes, so number of beams when it's increasing, it should constrain itself within the height. It should not go beyond that. So we have to define a height basically. And when it is vertical, so initial height can be, so we can set this as the preferred height of the z dimension. So I will just add a parameter over here. So height offset equal to 0, and over here, so total height of the horizontal fence is going to be the dimension dot z plus height of it. It's going to be like this: main column dot height of it plus main column dot dimension dot z total height. So now we are going to, so if the total height, let's say 150, and distance between them and 50, the number of beams can be just a 3 of, I mean 3 or something. So we cannot add this number of beams. This is going to be auto computed, right? And then we have the distance. So in 32, number of beam equal to total height divided by distance. No, not this. Main column dot distance. Okay. Now over here, I will delete this. Keep this inside the if else condition. If total height, height of it plus dimension dot base, number of beams is going to be added within the total height. So let's see how this works. Again, I think this is going to get reset. So cylinder, and we have also the view 200, 150, right? Now I'm going to change this to horizontal. Distance should be something like 5. Too much. Yeah. And if you add height of it on top of it, yeah, so height is actually increasing. Something like that. Forget the secondary columns for now. We will bring them back. But before that, we have to fix all these issues that we are getting. So we will set the distance a bit more. Let's say 50. Is that coming? Yeah, that's how it is. It is going to be. It is dependent on the distance actually, so it's going to auto calculate. We are not bothered with the secondary ones as of now. Okay, so now, just I will just clear this node so that we can figure that out later. But for now, let's fix all these issues we are getting. So let's delete the other spline just to understand how this issue is working. Currently, I have only 2 spline points, and its dimension is If I reduce this, oh no, this is also wrong. By reducing the dimension, yeah, this is also wrong. It is increasing both in the x and y direction. Should not do that. So here, yeah. So we have to actually not depend itself with the dimension itself. We will just set a height only. Instead of height of that, let's keep this as height. And by default, it can be 100. Okay. Or let's say 150 by default. So this is going to be height, and this will not be there. Cube is going to come horizontal. Distance is going to be 25, 50. Yes. And if I now check the dimension, it's a, yeah, here dimension is too less, so this many amount of cubes is generated. If dimension is more, let's say the dimension is increasing, so all these cubes are actually being combined to form this one giant cube. Now if I keep it like this, and then if I increase the number of line points, this is working perfectly fine. This is looking good, right? But then when I increase the dimension, see what's happening over here. This is overstretching. This is going to overstretch. I got it. This is going to overstretch itself. So we can restrict the dimension so that it never gets out of the bound. So for that, we have to compute the we have to compute how further apart this is being created. So is it dependent on this? Oh, it's also dependent on this. Got it? It's also dependent on this particular distance. So we have to also add a restriction over there as well. So if this distance, so if the if the orientation is horizontal, then this location is calculated from here. So this location, previous location, let's see, main column distance. Main column distance, this is dimensions of 6 plus main column distance. Yeah, I think we need a separate parameter from mean distance from ground. Mean distance, no distance, horizontal distance, or maybe vertical distance and horizontal distance. Vertical distance equal to, let's say, 25, and horizontal distance, let's say it's 100, something like this. This is for the horizontal category. This is general category. I mean, horizontal distance is always going to be there. Everywhere it is distance, I will change it to horizontal distance. I don't need to add it over here. I can directly keep it like this. Okay. So now we are going to compute. We are going to base this on the horizontal distance, but over here, yes, this is going to be vertical distance. Now if I compile, again I have to add this because I added a new parameter, so it gets reset every time I add a new parameter. Horizontal. Okay, height is I think too much. I'll decrease the height too. And horizontal vertical distance I can increase. If I decrease this, oh, if the vertical distance is decreasing, then this should not be happening because the height should, if the height is 64, then it is 64. It cannot extend. So there must be something over here that is wrong. So yeah. So this is actually wrong. It should be if height divided by, okay, yes, I think, yeah, this is it. This here also it will be vertical distance. Now it's going to be fine, I guess. So if I drag anything, yes, there. So vertical distance is, let's say, 25, or if it is 50, and the height is 150, yes, then three of them are generated. Now we are back to the issue which we need to fix. But first, let's just decrease the horizontal distance and see what's happening. I think there is maybe more issues over here. Let's just check this out. Yeah, distance from ground is also going to be, this is also going to be plus, no, okay, yes, vertical distance. Oh, I'm sorry. Yeah, I need this parameter. Float mean distance from ground equal to, let's say, 20. This is 20. Yes. If I increase the mean distance from ground, it's going to increase like this. If I put it to something like 30, vertical distance if I increase to 50, less number of beams are getting generated. If that goes to 60, it is going to rise up. Again, we can add a constraint over here that a number of beams equal to this can be added by mean distance from ground. If the it is still restricting itself with the total height. In that case, if it is 60, 5, this is 5, 50. No, this is confusing. Let's keep it like how it was before. So now, yeah, let's keep it like this for now. Okay. Mean distance from ground is 25. Now let's get back to this issue. If I decrease the horizontal distance, let's work from here. Here, horizontal distance is too much, so I'll just decrease this. And these all are combining themselves. So till here, I think it's fine. Whatever you do up till here, till here there is almost no bug. You can see these are properly connected, and these are not at least overlapping with each other. But as soon as you are decreasing the horizontal distance further, so that these are getting connected with each other, then as usual these will start to overlap slowly like this. We have to add a filter so that it never the distance should always be the uh, connected at least. I mean, the distance should be such that it does not ever exceed the dimension. So here you can see dimension is 150, and if the horizontal distance is also 150, then yeah, there is a little gap, and that's probably because of the, yes. Let's check this again. Main column distance, main column the dimensions of x. It is calculating this dimensions of a distance. This should only be valid equal to when if the orientation is horizontal, then it's 0 or it is okay. I think I need to add this first. Yes, now they're connected. They're exactly connected now. Now if you add this, then the, this is happening. We have to ensure that horizontal distance is never less than the dimensions. We can add over here. Let's set the main column distance with 0 and then add a condition if else, then main column distance equal to main column dot horizontal distance, else equal to column dot dimension x plus main column dot horizontal distance. Okay. Now we have to do that check if the horizontal distance is less than the dimensions dot set. Okay, so we have to do in mathematics. So it should be maximum of the two, max of the two, whichever is maximum. Right? Now, yes, now these are connected, and even if I reduce this, it doesn't matter because it's always getting the maximum of the two values. So if I increase this, so now you can see the distance is increased. Right? So if I change this back to vertical, yeah, the actual original fence is back right now. Now we have to figure out the horizontal, I mean the secondary measures as well. So keep this to 100 or 125, and horizontal distance let's put it to 25, and here horizontal distance can be 200. right? Now, if you set this to horizontal, the secondary columns are also back, and now you have to actually manipulate the distance. Like you can connect it. Now both of the secondary and primary columns are. So now if you decrease the height and if you decrease the vertical distance, you can adjust it. You don't need that one. And you can set the mean distance from ground. Perfect. For these, you can increase the height. Not the height, but the Z dimension. You set this to horizontal. Yeah, we have not yet added the horizontal functionalities for the secondary column. It is only working for the main column, as you can see over here. So this is only for the main column. And we need to figure out the gap that I'm getting in between. Also for the very last, something weird is happening, duplicating. We will also figure that issue. Let's see why am I getting this gap. So if the horizontal distance is like now it is getting perfectly aligned. If we increase the dimension, you can see the uh, secondary column is also moving, which is obviously not the right thing to do because it's horizontal orientation that only should work in the vertical orientation. And if I increase the Z dimension, yeah, this is why there is a gap. The distance is actually connected with the secondary column. So let's figure this out here. Yeah. Let's check out the code for the secondary column. So this is where that secondary column is working. And next primary distance, if it is horizontal, then it is dependent with the mesh dimensions as well. That's why if it is increasing, then it is horizontal, in that case, I don't want the secondary columns to be dependent on that, and that is going to be the sensible thing to do with you, right? If I set to 150, you can also do this. Mm. It's that is actually shifting somehow. Just that main column distance pixel, right? Is the available space in that case. Just the same thing. It's going to be main column distance by secondary column into secondary. The student will start off right? If I added P to it, now they are close to each other, but these are overlapping. So if you are actually overlapping, I need to have a start offset. Main column dot dimension dot a secondary column of dimension dot x. Let's see what happens. Now the offset comes in the y direction. I don't know why. Oh, that is why. I have to add a bracket to the duration. This is already been added. Why am I adding it twice? There is always gap where the secondary column is starting. The reason is these are actually meant to be vertically arranged and not horizontally. So this space is being created as gap. So to check this, it is adding the start point with the main column dot dimensions dot eight. So let's go back to horizontal and so check this. If this is zero, then also there is the gap. So this is the only, yeah, this is also being checked. So there are two places where the main column is being used. Yeah, apart from this is just calculating the number of secondary columns. But this is for the main column itself. Let's check the. This is the only place where it is being used for the main column calculation. So if no, what if I don't use this start point at all? Yeah, the start point was actually not very useful. It is not changing anything. So let's not use start point and we'll delete it. So this is fine. Now we have to see what's happening over here. It's horizontal distance, which are dimensions that we. So basically, this is the only place where it is being used. And location, yeah, this is another place. So this is the location of the primary mail, and that is being added over here. Depth is 0. I think this thing added from the very first, so we can just add a index of 1. Yeah, now there is a little gap in between. So let's get back to in the horizontal distance of 150. And this is 0, then this is absolutely fine. I mean, no, there is no gap even between the main columns. I mean, wherever the gap was more, even that is being closed over here. Even if it is very small, like 0.1, then also this gap is coming. Let's see where this horizontal distance is being used for second image. Over here. Let's directly add this. Because sometimes what happens, float point will cut off the value to the lowest int, and even I index is going to be even lower than that. Okay, now let's add. Yes, now I think it's fine. Yes, I think now it is almost equal. It's like different. Yeah, it's looking much better now. Let's move along the lines and all. So now if it is set to vertical, then there is this obvious overlap. So the main column distance is also, yeah, but this should be actually, I have to load the secondary column equal to main column distance. But, we need to subtract the main column dot dimensions of x. Solve anything. This is going inside, so I think the total distance for this should be, I will also minus subtract the secondary mesh dot dimensions dot x. Okay, now it is fine. Now the additional secondary column is gone and this is perfectly fine. There are a little issue still. And that's because of this turn. We also have to compute both the x and y in that case and the direction to accurately determine that. But we will fix that later. So now it's, I think, mostly looking perfect. If I now change this back to horizontal, so now increase the distance to 0.25, 50, 5. Now we have to figure out how we can. So if what number of secondary columns, now we can just do another one. Else, if this is horizontal, then I don't want to subtract either of them. Let's see what happens. Mm. Yeah, you can see the gap is gone, but this issue is there. So we have to minus the subtract the, let's remove that, and for the location we can just add this every time. Overlapping. think better approach is going to be, instead of making the secondary columns dependent on the main columns, we can, if we want one horizontal layout along with the vertical layout, so this should typically be independent of the main columns. Because of the horizontal layout, it doesn't matter about how much further apart they are. So the logic also currently not making any sense. So what we can do, we can have multiple main columns instead and have the secondary columns already separated out, because this is also where we can use this. I'll just revert back most of it to what it was before and use this to, I mean, use multiple main columns instead. So one can be horizontal and another can be vertical. So let's do that. I think we are fine for now. This let's just check if this is fine. So here we have this overlap. We are going to solve with subtracting. If this overlap is gone, now let's add multiple main columns instead. And we are going to add the array main column. So we need a little bit of structural changes over here. Let's comment it out for now. Just we'll add that later. But for now, let's we need to have, so this is common. So from here onwards, we need to have a for loop for the main columns. Now everything inside this is going to be here. Now we can do one thing. We can add a mesh info, mesh info, main column, equal to column I index. Let's check this now. Okay, there is multiple declaration of I index variables. Okay, so now there are multiple main columns. We are going to add them one by one. Let's add two of them. Let's have both of these. Okay, we can have a different tube for this. This is overlapping, but don't worry, we are going to set this horizontal. Yeah, like this. Right, so vertical distance is going to be 50, mean distance from ground 50, and for this height is going to be 200. Let's add a cylinder in this case. Something like this. Okay, now I think this is much better way to do it, having multiple main columns instead of secondary columns depending on main columns when the main column is set to horizontal. This is much better thing. So, and now we can have this. Okay. So if you play along with the spline points, this is going to be perfect, right? So for the vertical, these three parameters are not going to be used much. When it is horizontal, then this is going to be effective. If you set this to horizontal, then you can have a different distances and all. Right? You can, I mean, customization is completely up to you. You can do whatever you want with it because these two are independent. So changing this is not going to affect the other. So let's set it back to vertical because this is what is making sense right now. Now the next thing is going to be being able to add a gate over here. Okay, so now let's first let's um, add back the secondary column because we still want whenever one of the main measure is vertical. For example, if this is vertical, then maybe I want to have the secondary measure along with it. So let's give the let's increase the vertical distance. No, sorry, horizontal distance. A little more reasonable, like let's say 200. Okay. Now we can have one secondary mesh that is coming in between this. We can add this back. Regularly doing this. Right? But also, I mean, this is one secondary mesh is going to be influenced by both of these, which I don't want. So what I want to do is here we are going to determine with a variable which primary mesh it's going to be derived from. Let's add another struct. Struct is secondary strength mesh import, something like this. And over here, I will add two properties. One is going to be primary mesh index, and second is going to be this array of secondary mesh input. Also need to include this generated body. Now, instead of this, you can have just one of this. No, we also need multiple array of this secondary mesh info, secondary or secondary mesh info map. Okay. Now we are going to modify this. Okay. Over here, I will add another for loop. It will be for this secondary mesh info. Secondary mesh info map. Sorry, mesh info. So this is going to be primary mesh index. If it's matching the current index of this. So if this for loop main column is matching this, then the secondary mesh info inside this is going to be taken into account. Secondary mesh, sorry, mesh info, mesh info equal to s plus 1. And inside this, I'm going to add this. So whichever mesh index it is going to match, only that is going to be executed, and both, I mean, same mesh cannot be influenced by both index. So let's say I have two mesh infos and both of them having the index of 0, but only one of them can execute, right? Uh, no, it is fine. I think this is going to be fine. So let's just again build. Hi, hi Wikitudes. Can you hear me now? Is the volume clear right now? Hello. Okay, so let's get this again. Have this primary mesh, and then in secondary mesh info map, you can add this. Like primary mesh index, let's say it is 0 because I'm only interested in the vertical, not the horizontal one. Secondary mesh info, I will just add. I will add a cylinder. Yes, now it is dependent on the on this vertical mesh. So I will just manipulate the horizontal distance. So 25 or 15 maybe. And I can increase the height a bit. No, not the height, sorry. Because I need to increase the dimension. It's 180, let's say, or 170 maybe. Let's set this to 180. Yeah, now we need to fix this overlap issue again. So let's get back over here and this secondary column distance is going to be okay. So this distance by location plus direction into secondary column distance. Okay, let's get back to Fmat, load to int. Okay, yeah. Yes, so that overlap is now gone. So now we have this secondary mesh dependent on this particular main mesh. So if I set this to primary mesh index to 1 instant, then it is going to depend on this horizontal mesh, which as we have established before does not make much of a sense. So because this horizontal column should be independent with this vertical arrangement. So that's why it's better to have this as 0. And now we have set up a system where you can actually customize whether to use the horizontal mesh or the vertical mesh or both. I mean, as many meshes as you want. So ideally, this can also be used to create something like an electric fence, but I will just take a diagram, take a look into how electric fence work. I mean, how they actually look. Yeah, so typical electric fence is going to look like this, or maybe like this. So can we do something like concept art? Anyway, we have to understand from these diagrams itself. So Here we can create a main column that can be vertically arranged, and we can have some mesh like this, and then we can arrange a set of horizontal beams going in parallel, and you can also see a bunch of interconnected wires going vertically. That is again can be the secondary mesh spread across between these horizontal beams. So, and we have also these wires, additional wires going on. We currently don't have a system that can create this, but we can modify our system to make this work with this electric fencing as well. So we will do that later, and we will also create the gate in between the fences. Today we don't have the time for that, so we will continue with this on one of the future sessions, maybe tomorrow or later. So please subscribe to my channel, and this live stream is happening every day at 10:30 a.m. So please subscribe so that you get a notification whenever there is an update on that. And if you have any questions, suggestions, or feedback, please leave a comment. I will see you tomorrow morning, and also every week Tuesday in the evening I am I am live with in another live stream where I'm teaching the game development with Unreal C++. The exact timing is going to be, just hold on, let me just quickly check and tell you the exact timing for that. So this live stream is going to be 6 to 7 every week Tuesday in the evening, so in Indian Standard Time. So if you're interested to learn game development with Unreal C++, please uh, join today's session, and also stay tuned so that every week you can join the live stream and learn a lot about C++ game development. And if you have any questions, suggestions, please you get to interact with me directly over here, or you can also leave a comment and I will be ensuring that I can reply you. Alright, so that's it for today's session. I will see you tomorrow and also possibly today in the